We're going to be looking at some improper integrals. Okay? And we learned that when we're dealing with improper integrals, we get two types, right? One where the limit, or one of the limits that we're working with, is infinite. In other words, when we're looking at integrals, if either a or b are infinity, okay? And the other type was where one of the limits was undefined, right? And so because it was undefined, we couldn't evaluate the integral, so we would look at the limit as that value, or as we approach that value, what would the integral be, okay? So in this video, we're just going to look at type 1, so where one of the values is infinite, we're going to replace that infinite value with a placeholder, and we're going to evaluate what happens to that as it approaches infinity, either to positive infinity or to negative infinity, okay? So here we have the integral from 4 to infinity of 4 over x to the power of 5, okay? Now the best thing we can do is get ourselves a graph, okay? Because that'll help us understand what's going on here. So here is the graph of 4 over x to the power of 5. And we are basically being asked to find the value, if there is a value, between 4 and infinity. So if we had to shade that, it would be the region from 4 underneath the graph towards infinity, right? So the first thing we're going to do is we're going to have to replace that infinite number because we can't evaluate something with infinity. So we're going to put a placeholder there so we can assess the limit as we approach infinity. Okay. So let's rewrite our integral, right? We're going to say we want to find the limit, right? Now we need to define a value for infinity, right? You can make it any placeholder you want. Okay, x, p, you can make it q, whatever you want. Right, if I make it x, and I'll just write that as in red so you can clearly see it, approaches infinity, right? So we can change our integral now from 4 to x, right? I'm going to rewrite the function, right, as 4x to the power of minus 5 with respect to x, okay? Now I don't have infinity in the integral, I just have a placeholder, and I can evaluate that as it approaches infinity. So like we always do, the next step is to anti-differentiate to find the primitive function. So we need to anti-differentiate. We're going to reduce the power by 1, so that's going to become x to the power of minus 4. And I'm going to divide by the new power minus 4. Right, our limits are 4 and that dummy holder x. Okay, we can tidy this up a little bit further, and we can write this as minus 1 over x to the power of 4 from 4 to x. Okay, so just think about x as a placeholder. It could have been a number, right? But in our case, it's holding the place of infinity because we can't quantify infinity when we put it in. You can't put infinity into your calculator. Okay, so we need to still assess this limit. Okay, so we're looking for the limit as x approaches infinity, right? And this will be of f of my upper bound is x, take away f of 4, okay? Let's replace those with the actual numbers. So we have to keep writing this limit as x approaches infinity until we actually evaluate the limit, all right? So I'm going to replace everything with a little x with a big red x, okay? So we're going to have minus 1 over, we would have x to the power of 4 take away minus 1 over x in this case is just going to be 4, so 4 to the power of 4 so we're still having to write this limit because we still haven't assessed the limit as x approaches infinity of minus 1 over, well, this number x, whatever it is, to the power of 4, take away, right, this take away a negative number is going to give me a positive number, right, and we can quickly go 4 to the power of 4 is 256, so we're going to have plus 1 over 256. Okay, right, I'm now ready to evaluate my limit. And so what I can do is I can say, as x approaches infinity, so as that x gets bigger and bigger and bigger, what is happening to minus 1 over x to the power of 4, right? Well, we can see as we get bigger and bigger values, our denominator is becoming infinitely big, which means that that thing's becoming very, very small. In fact, it starts approaching 0. Okay, so I've evaluated my limit now, so I can stop writing this limit is equal to. Okay, and we can just say that this is equal to, well, we've evaluated this part here to be 0. So as x approaches infinity, that just becomes 0, right? And we're going to add this 1 over 256. And so I just get left with 1 over 256. That is the value of my integral. Okay. So this was a nice one where things are defined. Okay, there's a defined area. Let's have a look at another example where the improper integral might not exist. Okay, so here we have the improper integral, right? Again, from 5 to infinity of 2 over the square root of x plus 4 with respect to x. And the question asks us, show that it does not exist, right? So they're kind of hinting that this is not going to have a finite value. So here's the graph of this function, okay? Let's pop it up over here, right? And you can kind of see from 5 the line going towards infinity. So we're going from 5 towards infinity over here, okay? You can see that that blue line doesn't really touch the x-axis. In other words, it gets close, right? But it doesn't get so close that it's ever going to touch it, right? So we can kind of see that this could go on forever and ever and ever, okay? So let's prove that. So we can't have an infinite number in our integral. So we're going to replace that with a variable. And we're going to say, well, let's look at the limit, right? And I'm going to replace that with x again. X approaches infinity. And I'm going to rewrite my integral with my new variable. And I'm going to change this so that I can anti-differentiate. So we're going to have x plus 4 to the power of a minus half, right? With respect to x, okay? So from here, I can just anti-differentiate to find the primitive, right? I still need to keep writing that this is the limit as x approaches infinity, okay? Because we haven't evaluated our limit yet, so we need to keep writing that. If we don't have this limit as x approaches infinity, then we're not evaluating anything sensible, okay? So let's anti-differentiate. So this is a reversed type chain rule. So the first thing we do is we increase the power by 1, so we're going to get positive a half. We're going to divide by the new power, and we're going to divide also by the constant in front of x, which in my case at the moment is just 1, right? From 5 to x. Let's just tidy this up. This is still going to be the limit, as x approaches infinity, okay, of, well, that half is going to jump up to the top over here, okay, and we're going to get 4x plus 4 to the power of a half, right? We can actually go one step further and we can rewrite this as 4 square root x plus 4 from 5 to x, okay? So let's now look at these. We're going to still say as x approaches infinity. What we want is f of our upper bound is this variable x, which we're going to evaluate. Take away f of 5, right? So it's still end and start, right? Start or end, take away start. Let's actually put the numbers in now. This is still the limit as x approaches infinity, right? We need to keep writing that until we evaluate the limit, right? So f, if I replace x, I'm going to get 4 square root x plus 4, take away 4 square root 5 plus 4. So we can do a little bit of tidying up. We can say this is the limit as x approaches infinity of 4 square root big X plus 4, take away, I'm going to get the square root of 9 times 4, so I'm going to get take away 12. Okay, right, I'm now ready to assess my limit. So I'm going to say, as x approaches infinity, what is happening to 4 square root x plus 4? What is it approaching? Okay, now we can imagine, as we put in bigger and bigger values for x, right, even though we are squaring that number, right, or square rooting that number, it's going to get infinitely bigger and bigger and bigger. All right, so we can say that as x approaches infinity, this thing also approaches infinity. And because this thing approaches infinity, right, we can drop the limit now because we've evaluated it. This is just equal to infinity, because as that thing approaches infinity, we have infinity, take away 12, right? We can't work with a number that's infinite, so this is undefined. So we can state that the integral from 5 to infinity of 2 over the square root of x plus 4 is undefined. Okay, so that's just two quick examples, right? The first one where we were able to find a finite value, in other words, the value converged towards a certain number, right? In our case, it was 1 over 256, okay? And the second one where sometimes, right, the integral will not converge towards some number. It's just infinitely big, and so we can't assess it. It becomes undefined, right?